Everyone, a very warm welcome to Avaana India Climate Week 2024. And we are very grateful to Spectrum Impact, to Mirik and his team for helping us put together this roundtable and working throughout the last 3 weeks on detailing out the agenda, the questions, so that we could have a deep dive into the topic today of alternate and next generation materials. Great. So what I would like to begin with is if everybody could just give a very quick introduction of themselves, and then I would invite Mirik to talk about the topic. Starting with Professor Bishnoi, please, would you start?
Hello, good morning, everyone. Thank you for inviting me here. I'm Shashank Bishnoi. I'm a professor of civil engineering at the Indian Institute of Technology, Delhi. And one of the things we've been working on, well, the most important thing we've been working on is something called limestone calcined clay cement. And we've also been receiving support from Spectrum Impacts on this. So looking forward to this discussion.
Great. Dr. Saiyed, do you want to go next?
Yeah, happy to. Good morning, everyone. I'm Taslimarif Saiyed. I work as the director and CEO at CCAMP. At CCAMP, we intend to attract disruptive ideas in life sciences and help them go to the next level. This go through the broad spectrum of healthcare, agri-food, and environment. We have till now supported more than 500 such innovative ideas. Some of them have done phenomenally well, including fantastic work by C6. Sowmya is here, so I don't need to speak much after that. But we are actively building new capabilities in frontier of science-based ideas, and happy to share what we are looking at, what we are seeing these days, how amazing ideas are coming, and where we want to make next steps. Thank you.
Great. Thank you, sir. Jagdeep, sir, do you want to go next?
Yes, for sure. A very good morning, everyone. My name is Jagdeep. I head the R&D Center for Nestle, based out of Gurgaon. Pleasure to be here. As part of R&D, we do keep on working with not only alternate materials but also alternate technologies, which can help us to unlock and leverage, with some new opportunities in the food ecosystem. Very happy to have a discussion around on different areas that we are looking at, but more to also learn and see what are the other things that are coming up.
Amazing. Harini, ma'am, do you want to introduce yourself?
Sure. Good morning, everyone. I'm Harini, and I'm from Gobain Research India. We are located in IIT Research Park, and it's been almost 10 years since this was established. We are one of the 7th R&D centers globally for Gobain. We work a lot with alternate materials, and we also work focused towards sustainability and lightweight construction. And I think this is a very good forum to, share whatever knowledge we have and also obtain from each other. I'm a civil engineer by background, and our R&D, the R&D that I lead is more on gypsum and construction solutions. Also, I lead the efforts on building science, where we focus on comfort, thermal, acoustic, and so on and so forth. So, thank you.
Great. Sowmya, would you like to go next?
Sure. Hi. Very nice to be part of this panel. I think discussing something very, very important and relevant. Sowmya Balendiran, co-founder and chief business officer of C6 Energy. At C6, we're trying to look at ocean agriculture, which is cultivation of seaweeds at scale, and then taking these seaweeds into a variety of products for use in agriculture, food ingredients, and also biomaterials. The long-term vision of the company is to see if we can also take this into biofuels, but essentially looking at how can you play along the fossil fuel value chain without going through fossil fuel, but directly from plants. That's what we're working on. Looking forward to an exciting discussion today.
Amazing. Arpit, up to you next.
Hi everyone, thanks for having me here. I'm Arpit, founder and CEO of Dharaksha Eco Solutions. So Dharaksha word comes from two Hindi root words, Dhara meaning earth and Raksha meaning saving. So the company was started with the vision to save the earth from the problem of pollution. We are a biotech-based alternate materials company. We are building solutions to petroleum-driven products like plastic, thermocol, etc., using agri-residue and biology as the forming factor. Very excited to be here and learn from everyone.
Amazing. Uthara, over to you.
Hi everyone, excited to be here today. I'm Uthara and from Social Alpha. At Social Alpha, I lead all the work related to new materials, circular economy and allied sectors. So this includes thesis development, scouting for startups, programs, due diligence, as well as portfolio management. So yes, like all of you mentioned, a very relevant topic today and looking forward to the discussion.
Amazing. Mirik sir, over to you. Please introduce yourselves and take it away.
Yeah, good morning all. I'm Mirik. I'm from Spectrum Impact at Spectrum, we deploy capital in a wide variety of areas in climate, ranging from as deep as energy, which is nuclear fission and those kind of things, as well as business model innovations. And materials is something that is very close to my heart. I'm being a material scientist by education myself. So yeah, and I'm thankful to Avaana for in their whole 1 week. One of the days is what we are doing in terms of having a roundtable in the morning and having a visit to Aarti Industries, which is our main business, the site visit in the evening. So yeah, excited to be sort of leading this panel. A couple of asterisks I'd like to add. This is my first panel to lead. I have been on the other side many times. So apologies in advance in terms of flow, format, content, and those kind of things. But I think hopefully, since the mission for everyone is the same, we should be able to get a good outcome on those lines. I'll, in terms of setting a context, I made a small presentation. I like to do that because it helps me also think about what the broader scenario is, and it's a small 7-8 slide note for everyone, for us to reflect upon, and then obviously we can take not only reflections on that, but then specific questions. First, we'll focus on more on the corporates and the startups and the technologies which are building, and then obviously we'll go slightly on the investment and the broader ecosystem landscape which is there. So yeah, before I start, I think I'll also mention one interesting incident in my life, which so when I joined IIT Bombay in material science and metallurgy, generally to get material science and metallurgy is not a good rank in IIT Bombay. It's like you're in the 2000s and it's almost at the fag end of the career choice. And our professor told us this thing that, look, materials are the most important thing in the world. And I was like, they are just trying to cheer us up, right? In terms of you didn't get a good rank, and but imagine that's a good good area to work on. I think it was only after passing out and a few years later when I think that meaning really came to my mind that, look, that was a very, very potent point that was made. And now as I reflect upon the world and the climate crisis, and if you look at it, it's all about materials and energy at the end of the day. So yeah, just that reflection. Let me start this off with a short presentation.
As Mirik's presentation comes up, can I just take a minute to see the diversity in the room? I think to build an ecosystem, we need everything from large corporates like Nestle, Gobain, to startups which have proven like Sowmya, and the fledglings like Arpit, to accelerators, C-Camp, incubators, Social Alpha. And I guess really, Mirik, you sort of bring it all together, and with academia, Professor Bishnoi, I think it's a very, very interesting and diverse panel where we see perspectives from everyone as to how they are coming at building at it. So really excited about this panel.
No, I think that's true. I think, and that's the whole system thinking and ecosystem approach we need to leverage. And I think the whole idea is at the end of this panel, if we can get those distilled 2-3 points, that then we can either come out as a policy paper or key action points for the whole ecosystem. So yeah, I think the title itself, I think one of the discussions that we had with the Avaana team was alternating materials is a good thing, but we should add next generation as well. And I'll deep dive why that next generation point is important, because we obviously want to push boundaries, not only just meet the current expectation. So from a definition perspective, obviously people know what materials are, but just to give you the textbook perspective, it's basically substances or mixtures which constitute physical matter and to create products. I think the thing that I put as my personal reflection as I think of materials, I always think of atoms and molecules. And it is this arrangement of atoms and molecules in a peculiar fashion, which in the end gives properties which we want to add to specific applications, right? So if you look at silicon or the chip industry, then you have this crystal structure of silicon and you doped it with some P-type or N-type dopant, and then suddenly that you get the property of a band gap which is suitable for your example. But the whole point, at least when I look at it, it is this collection of atoms and patterns at the heart of it. And I think this, everyone knows this, but I think this context helps that humanity or the human progress has been actually defined by materials at the end of the day, right? And you had the early Stone Ages, and then you had the Metal Ages which were there, and now in the last 50, 60 years, the plastics and the polymers, which has created its own challenges, but again, which are there, concrete, steel emerged, concrete and steel combined to create this big skyscraper and the modern way of life in terms of urbanization. And now I think we are going to the current age where you are talking about nanotechnology, where we are talking about the next generation materials, whether we are trying to decarbonize the existing materials or create the new ones. So I think it is also imperative on this group when we go outside to people who do not understand materials, just to ground them on the fact that, look, so society is in the end determined by the quality of materials and what their properties are. So this is the, I try to, when I said the word, the materials and the properties, we try to list that down in a clear way. So at the left, we will see the types of materials. So these are the materials that we know of. But I like to think of materials not as in terms of metals and plastic. I like to think of them in terms of the properties that they give. And if you change this perspective, I think we can then start looking at, like, for example, what many of you are building in terms of biomaterials and bioplastics. In the end, what we are trying to do, we are trying to take the materials at the left, but we are trying to ensure that the properties that they are deriving, we are deriving from another source. So rather than the material itself, we want the properties at the end of the day. And these properties, this is not a exhaustive list by any stretch of imagination. It's more about the mechanical, the thermal, and in fact, when you look at the next generation materials around metamaterials, you are actually pushing the boundaries. There are materials which right now have negative refractive index. So there are very, very interesting things going on in all of this as well. Again, I didn't mention LC3 on this slide, and this is a relationship with Professor Bishnoi that goes a few years. But the idea for this slide is, look, when you talk the alternate materials, what we are trying to do, we have a set materials which has been incumbent and being used for the past 20, 30, 40 years or even more. We are trying to replace this, pretty much match the same properties. We are not trying to upgrade the properties, but maybe create a low carbon substitute or a low resource intensive substitute. The next generation materials, I would, in my definition, and again, this is open for discussions and thought processes, will be that can we augment the properties and sort of create new boundaries for which new applications can be created. So if you look at transparent conducting glass, that's sort of like a next generation of material, superconductors, specifically high temperature superconductors there. Now, the bigger reflection, I think, on this slide is the last one. So I will give you the example of LC3. I would consider, and I think Professor Bishnoi can argue with me if that's fine, is LC3 will be an alternative material because you are trying to replace the clinker and you are trying to match the property of an ordinary Portland cement. But if we add the next generation material, like a nano material, like nanosilica and others, or graphene oxide, then suddenly you are able to take it to the next level. So innovation is not going to happen in silos. Innovation is going to happen while, say, some of you say, Arpit, if you are developing something in your space, there may be some other solution which can create properties which are not naturally part of the current solution. So the idea for this is like, there are sort of two parallel tracks of solutions going on, and they are actually, interestingly, very intertwined with each other. And I think coming to climate, at least at Spectrum, our belief is that climate essentially is a materials and an energy problem. And if you look at actually energy also will delve down into materials problems. All the energy solutions that we are looking at right now in the world, whether it's solar panels, solar is effectively, you are having a material like silicon panels, right, at the end of it. And that's materials innovation that has happened. If you look at wind turbines, so the strength to weight ratio for the wind turbines to be really powerful is defined by the polymer, the epoxy resins and things like that, which is again a material solution. And simultaneously, there are so many other areas. If you look at the cement side of things, cement, steel, plastics, all the three are big emitters in themselves. So the question is, it's a loop. Like, are we seeking materials to power energy solutions, or basically is the material innovation going to power the next sort of set of energy applications as well? So for example, when you look at aircraft efficiency, if your thermal resistance or the alloys improve, then you can run the aircraft at a higher efficiency, which then creates that lower fuel requirement. And that combined with what Sowmya mentioned on the biofuels. So sustainable aviation fuel needs to be solved from either from a bio source or a plastic source or whatever like that. But you also require ceramics or high temperature resistant alloys to ensure that your requirement of fuel also decreases. So it's again, to my earlier point, it's a complementary of these two dynamic forces that needs to be solved. So working on each silo may not be the best. And I think, and in fact, that can be a good point for today as well, because ARPA-E in US, how it functions is like this. They give a target and they create cross-functional teams. Someone working on the biofuel, someone working on the jet engines, and it's a combined target given to them that, look, we want to reduce the efficiencies rather than individual targets. This, I think everyone will agree with the long gestation period of material innovations, I think. And this is also where we as sort of pioneers in the space need to also tell the community, tell the other investing community as well as support community that, look, it takes time. And look, nanomaterials, a lot of these things have been known. Graphene was invented in 2003. The first applications are coming out 20 years later. Other nanomaterials were invented even earlier. First solar cell prototype was done in 1960s, right, in the Bell Lab. So this is a technology of atoms, as I like to call it. It's not a technology of bits. And in technology of atoms, it takes time, it takes patience. And if you have the mindset of a very, very quick journey, I think that is more detrimental. And I think Professor Bishnoi can allude to the time it took for LC3 to come as a concept and where it is now. I'll just, this is some of the focus areas that I am looking at in the material space. Obviously, it may not be relevant for all the work that has been happening in an individual basis. But to my earlier point, these are the other things that the world is working towards. And can there be cross learnings, cross collaboration with those areas? I'll quickly go through them because at least I find it interesting. And I think high temperature superconductors, I think they are in that inflection point right now. And once this manufacturing technology is figured out and there are people working on this world, they may be a bedrock on which a lot of future technologies on the energy side will work. High entropy alloys is a very unique space. So normally alloys are defined as impurities in a 1 to 3 percentage points or 5 percentage points in the core metal. This new class of thought processes is where you mix almost at an equal percentage point. So you have like 5 metals at 20%. And early signs are very promising, but this is a long way to go. Ceramics, people know ceramics well. Now this is a new sort of type of ceramics, which are polymer derived ceramics. And because of the versatility of the polymer side, you can get a wider range of ceramics and wider combination of ceramics. Again, suitable for space applications, high temperatures and things like that, leading to a lot of efficiency. Like biomaterials, I won't go too much into deep. We have more knowledgeable folks here. But again, I think everyone would agree that biomaterials are at the inflection point. We need to continuously develop again, I have mentioned strain development and selection, but I'm sure the panelists will have much more better idea on that. Catalyst, again, very, very fundamental. And I think there is a new thought process around single atom catalysis, which is there. Again, it's a combination of material and process innovation that is happening where you can dramatically reduce the catalyst requirements. So everyone knows the mRNA vaccine. So the mRNA vaccine was actually made possible by material innovation. So this was the lipid nanoparticles. So lipid nanoparticles, and I think at CCamp, doctor would know that lipid nanoparticles are a very potent type of nanoparticles in which can actually hold the mRNA within this globule, and then the mRNA goes and actually does its function. And mRNA technology is potentially going to revolutionize the whole world in terms of the vaccines and other areas as well. And those are in the end basis around some nanoparticle innovation, which is already there. People also know about 2D materials, whether it's graphene or others, but I think there are a lot of non-carbon 2D materials which are out there, molybdenum sulfide being one of them. But there are others as well. So I think that industry is also now at that point where a lot of applications are there. So one of the biggest applications is graphene additives in either composites or cement and concrete. Again, not fully done yet in terms of application testing, but it's the right way to go. MOFs and COFs. So these are metal organic frameworks and covalent organic frameworks. So these are again a very, very interesting class of materials being developed at the lab and pilot phase, which have application. So MOFs are currently being looked at dehumidification application, which can reduce your energy use in HVAC system, which is relevant for every one of us. So again, that's a pretty much a material innovation. Covalent organic frameworks is you replace the metal with another covalent compound. I think they are still slightly lower in the TRL scale, but important. Membranes, I think, as Swapna would also know, I am quite focused on membranes in life. We actually funded a large membrane research center at IIT Bombay. But the whole idea is membranes are going to be a very big technological area for energy, water, and health. And how I look at membranes is actually combining with them with MOFs, combining them with the nano 2D materials and others and biomaterials, and create sort of this next generation of membranes, which can make desalination more effective, dialysis more cheaper for everyone to use it. And the last but not the least is metamaterials. So metamaterials are basically you engineer the materials to get the properties that you want. And the properties is not like a sum of its part. It's a unique property. So negative refractive index is an area. And people are, again, early stages of development. So I wanted to put this here, not from the point of view that this is the work set that is happening maybe in this room. Some of it may already be happening. But to say that, look, the material world is very, very vast. And although we were having this 2-hour panel, I think it will require more than 2-3 days to really go down it. So it's important that we reflect upon these points and then try to take this thread and apply it in whatever action that we are doing. I think this is the last slide pretty much, but the whole point here is on, this is sort of the white paper, like the crux of it as we develop it more. Like sustainability is going to be a key focus for sure. So apart from just the properties, which are important, if you have a property which is important, but if it's very high carbon intensity, then that's also not going to work. So the balance is very important. This group is an example of collaboration that we need to figure out, academia, industry, corporate, startups. I think the areas of plastics, concrete, steel are definitely very, very big. The numbers everyone would know about, it's only materials are only going to get more and more important in the world. And yeah, this is sort of a call to action for every one of us to really start working on in collaboration, work on this industrial partnerships and policy support. So yeah, that's pretty much it from this presentation viewpoint. So hopefully people got, at least my perspective, I had to set the context and hopefully that's taken care of. Any
Master class.
No, and if we any quick reflections before we sort of dive down to the specific first focus area of this discussion, which is on emerging technologies and corporate vision.
So I had a point.
Sure.
So one thing that you said is that, we have to develop properties and new materials. One thing that I personally feel as a challenge is sometimes we don't know the properties that are needed. So I'll give you an example. This is a very recent thing that came across. So we are making mycelium panels. So basically this is, we've modified a mushroom strain, and we are able to make biomaterials using the roots of mushroom, which are known as mycelium. Now we've been able to get a very good binding strength biologically without using any resin. Now we were using this as a packaging application because this was something that was most visible. Recently, I came across a research wherein these mycelium panels can be used for shielding against cosmic radiation for the space tech application. Now, this is something I had no idea of, and I could have never optimized for this property. This could have been a very useful or a far more valuable property, that these materials are very lightweight in nature. So this is potentially the lightest material that can absorb the cosmic radiation to that level. So this is where I feel sometimes stuck. So also you also gave an example of solar panels. Solar panels has been a very long journey. Initially, when somebody would have identified that certain doping would have a photocatalytic effects, they would have not imagined a situation where it could power or fulfill our power needs to a decent enough number. All that was earlier stages was just a sensor that if there is enough light or there is not enough light. Generating power was never a thought process. Similarly, what we are at right now is biologically we are trying to generate electricity, but again that is minuscule amounts of electricity. So we are not able to foresee that any coming point in the future we would be at a stage where it would be able to power anything. Right. So my point of view that has, where I feel a lot of confusion is, how do we decide on which property to focus on that has a potential for the future, given that we are not able to imagine or visualize what those properties could imply. Did I make my question clear?
Maybe I can try and take that up with, because I think very fair and classic problems when you find a new material and where all the applications can go. So when we were also looking at initially on what materials and what applications we can look at is, I think I had a very similar question to an advisor we had, and what he replied is, go back to how plastics started. When plastics started, they didn't start with all the plastics that we have today. Today HDPEs, PETs, PVCs, you name it, there's a whole bunch of things. It didn't start with all of them coming alive on day one. So what happened is you kind of make an application, you use the material for that, and then it keeps forwarding more and more, whether it's small modifications on a chemistry side or an application side, and that kind of opens up the whole window. So I think for us, when we were looking at seaweed materials, from this particular point of view, what came clear to us is, look at what your material can do today. So for us, we had some very good properties on some side and very bad on certain other sides. There's like a whole list starting from your WVTRs, OTRs to your strengths and impact stress and everything. And having a biomaterial which would check all those boxes is a lot more difficult than what you can think of. So I think we started kind of taking what works for us and then superimposing it on applications to see what might work, if that kind of answers. Because, applications can be really unlimited over a period of time, but we all start somewhere and then build from there.
I think that's a fair point, as in, I would also echo that. Look, the properties, the perspective that I was trying to bring is, look, there has to be an element where you are constantly looking at the properties and the application mix as a combination. At the start, obviously, we would want to focus on what is known, but I think as the whole overall ecosystem develops, there will be use cases, and sometimes as a company, you may also need to hold back. You don't need to develop everything as well. Sometimes you will have to approach like, this is my core focus, this is where I'll build the scaling up strengths and then take it to the next level. Right. So I will come to Professor Bishnoi. Professor Bishnoi, I think, can you highlight your experience in the similar light of how LC3 began and how did you look at OPC as a challenge and the whole perspective, again, what properties that you are trying to match? If you can share that, I think that will be also good for the group.
So something that you said, I hope you can hear me clearly.
Yeah.
Yes. So something that you said was very interesting, that we have been focusing from the start to try to match the properties of the product that's currently available in the market. And the idea there was ease of entry into the market, because if you change the product and the performance at the same time, then you have to train people on two things. First is you have to tell them that you can use something new, and then you'll have to train them on how to use it. So we had been focusing on that. With that, even with that kind of a focus, it took a long time. For example, India was one of the first countries to standardize LC3, even though the process of standardization was relatively quick.
Professor
Within 4
Bishnoi,
years, we were
for
able to
what
get the
I
standard.
know, you and I can talk about LC3 like it's very known. If you can
Oh,
just
yeah.
highlight LC3
Yeah,
for
all
everyone,
right.
I think it will be important.
Give a bit of an introduction first. That's what. Yeah, I saw a familiar face and I started going off as if everybody knows about it. So the idea of LC3 was that we wanted to have a more sustainable alternative to the cement that is there right now in the market. Now, cement might sound like something very boring and something people would not care about, but cement is the production of cement itself kind of contributes to 7 to 8% of the global CO2 emissions, just one product itself, which is huge. And cement has also been identified as a hard to abate sector where there aren't that many solutions to reduce the CO2 emissions. And there are two reasons because of the CO2 emissions there, because of which the CO2 emissions arise. First is the large amount of fuel that is used for production of cement. It's produced at 1400, 1500 degrees centigrade. And the second is the process itself. We convert limestone into lime, releasing carbon dioxide. So the idea was that if we can reduce the amount of material that the production of which is leading to so much of CO2 emission, we would be able to develop a more sustainable product. Well, the idea initially came from Switzerland and Cuba. So around the time when I was doing my PhD there at Switzerland, and then afterwards I moved here in India, and we decided to work much more on this. So what we're doing is we're reducing clinker in cement, which is like 90 to 95% in ordinary Portland cement, and pozzolanic cement at 60, 65%. What we do is we try to reduce the clinker down to 50% was our initial target. But right now our studies are showing that even with just 30% clinker, we are able to match the performance of OPC in many applications. So that was very exciting for us. Now, getting a cement accepted is not very easy. Accepted as in accepted not just by the market, but even by the people who are going to produce the cement. So it's not just about getting strength. So there were a lot of things that we had to work on. Initially, we had to kind of work on the resources and understand if the resources will be easily available or not. We had to do a lot of science in the lab to see it can be used easily, the durability will be good, show this in the field. But even then, people don't get convinced very easily. The construction industry is already known to be, if I can say this, notoriously conservative. But at the same time, it's also difficult to convince somebody to take an economic risk. So asking a company to shift their production to something like LC3 would be asking them to make a leap of faith because it's a new product for which we don't understand how well the market is going to accept it. So there are a lot of complicated things. A lot of people might ask that, okay, right, you've done the experiments in the lab, but show me a building that has been standing there that has been standing there for 50 years made with LC3. We have to tell them, well, that's not possible because this was just invented 15 years ago. So there is no building that has been there for 50 years. So it becomes like a chicken and egg problem. I can't make a building unless there is a production of the cement, and people are scared to make a production because there is no building yet, kind of thing. So it was a very interesting journey that we made. Right now, it's commercially available in around 15 countries. India also, hopefully very soon, hopefully this month, next month. But the interesting thing there is that it's not just about the science or the technology. It has a lot to do with the society, the economics, the psychology of the people as well at the same time. And there are so many, like you were mentioning about those, the panels for space applications. There are so many things that, recently we had this scale event in Mumbai, where Mirik had invited us to put a stall over there. And we had discussions with people from other industries, chemical industries and so on. And we realized things that were already happening in the other industries, which could help us in improving the performance in LC3 even further. So we can't work in silos. We have to develop it for the applications that we expect our cement is going to be used. But at the same time, we have to be very aware of the developments happening in the other fields. At the same time, others have to be aware that we are doing this so that they can come up with ideas. to support us. But just adding one more thing, taking it to the next level is also going to be very important. I know right now the construction industry expects a certain performance of cement, but in the future, that performance is that expectation is going to increase. And when that expectation increases, we hope to be ready with solutions like nanotechnology, like Mirik was talking about. So those things also have to keep happening at the same time. So
No,
Mirik, have I been able to give the...
I think that's a very valid point, and I think it segues well into the next speaker in a way. But the fact that I did not even mention the softer skills in the presentation, I think that was a miss at my end. The materials change itself is a journey, the convincing of folks. And I think to that point, Harini, if you can highlight being part of a corporate, and there is and I am also part of a corporate, there is also sometimes internal convincing that has to happen, that let's spend time and energy either testing external technologies or even doing our own internal research. So in your material space, specifically around construction, if you could say that, what are you working on as alternative materials, but also this push and pull between innovation and conservatism in terms of materials change? That would be interesting perspective for everyone.
Sure, Mirik. First, I would, like to touch upon this point about whatever material you make, however robust you make, we also have to keep in mind that installation varies quite a bit in the country from region to region, and it can be misused. And India being hot and humid climate, again, there are climatic issues that would affect the product. And on top of that, the installation procedures, the misuse is going to create a lot of issues. However, Gobain, as you all might know, we are more a glass company. That's how primarily Gobain is known. But that being said, we are into many other businesses as well. So Gobain provides gypsum-based products and system solutions for various use conditions. We have regular plasterboard for decorative purposes, and also we have performance-related boards, say for fire, moisture, wet areas, durability, robustness, acoustics, and very recently we have also commercialized exterior products, which can be exterior gypsum boards, which can be used. And we also have complemented with, this can be complemented with insulation products based on glass wool and rock wool to enhance thermal, fire, and acoustic properties. We also have construction chemicals. These are towards producing sustainable concrete with alternate and recycled ingredients. So we are moving from products to solutions. So we have a lot of materials which can fit the waterproofing, repair and rehab market. I mean, which is a huge market in India, especially with the high rises that we have. This includes, improving the durability and enhancing the usable lifespan of these buildings. A lot of solutions are focused towards, river sand-free solutions, less water to support circularity initiatives, and so on. Many of these solutions that I just spoke about have low carbon footprint, and it enables lightweight construction, which is our focus. And it also, compared to the traditional materials like concrete, brick, and so on, we have this as a journey towards low carbon footprint. So that is our main focus. And I don't know if I answered all your, if I answered your question.
Yeah, you did in a way, but one additional point there is, in this journey of low carbon, there sometimes is a green premium attached, because there is technological development, application development, and awareness that needs to be created, which causes the price of the product to increase. So how have you seen at Saint Gobain that particular aspects in terms of marketability of the product? Is the adoption from the market a bit resistive to begin with, or are they open? How would you say that?
I would say it's more a push from our end. It's not always a pull from the market. That being said, there are few companies and corporates, say, for example, the Googles and, few other companies, they look for products which has low carbon footprint. In fact, we have EPDs for most of our products in glass and gypsum. And these are some of the requirements for them to file, LEED and other initiatives also from their point of view. So it's I wouldn't say it's completely a push from our end. As I said, there are few corporates who are into this space and who look for solutions of this kind.
I think the two takeaways that I think I take is, one is this geographically linked challenges as well. One thing is you are making a material for a particular in the lab and in those conditions, but if you go to Northeast where rains will be a different issue than Rajasthan, I think that causes a lot of changes in that. And this perspective of that good procurement strategies by at least the large corporates are an important incentives for material development that you mentioned. I think that also is
Absolutely.
I think coming to both Arpit and Sowmya, in a way, both you are working on the biomaterial side of things. So obviously, Arpit, if you can just, you did share about what you are doing in terms of mycelium and in the packaging space. One question that I had, and it's again the same similar to Sowmya, in the biomaterial space, the quality consistency also becomes an issue because you are dealing in the end with some sort of an organism in terms of variability factors are quite large, whether when it is being farmed or how it is being grown and things like that. So how do you see that as a challenge? And when we talked about properties, if you want to get consistent properties, in the end, that will be linked to the type of growing infrastructure that you may have. So could you just touch upon those part of the problem statement, and are there challenges in terms of scaling up when quality is such a crucial aspect and it is very variable as compared to a fossil source where I can really get the specs nailed down quite easily?
Great. Do you want to go, Arpit, or should I go?
Nope, you go first, please.
Okay, great. So, Mirik, very good question. In fact, see, the one of the most critical things when we started looking at biomaterials itself, we didn't look at applications first. The priority for us was how do you first make a very scalable, repeatable base raw material, which can then go into a variety of applications, right? See, what we don't realize is we say fossil fuel is so standardized, but actually there are multiple varieties of fossil fuel. It's not one kind of crude that you get, you all the way from heavy crudes to light crudes, and different soils give you different things, which is completely different. But what the industry has done is it has optimized certain specific parameters, which are the most important contributors for the final applications that they're targeting. So what we started looking at is, and this is still work in progress, I can't say that we've completely finished it and we have a final raw material, which is like ready to go tomorrow everywhere. What we're trying to do is we're analyzing and taking out those key parameters, which we believe would be the most important in getting to the final applications that we are targeting. And then you standardize that. How do you standardize it? Like you rightly said, you can get biomaterials grown in different parts, different seasons, different ratios, and then identifying those key things and what process you deploy to bring out a final material, which is always consistent with your end specifications. Because the last thing, we have Nestle and Saint Gobain on this team. I think both of them will just really be shocked if they say, I'm going to get a material which is going to be inconsistent every time. Nobody will want to even touch that material, let alone going for a consumer launch, right? So these are some things which is important. And I think that's where we first started. The second thing is you also don't want to invent a new process which means you want to make the entire industry change its process which is existing. Nobody wants to waste their assets. Most of these industries are assets heavy, they're driven that way. So it's also important that you kind of make a raw material which fits into the industry as is. So these were a couple of very key important parameters we've been focusing on. And when we get to the end of the road, I think that's what is going to really differentiate on how this product will perform in the market than regular biomaterials and the issues that you had raised earlier. I hope that kind of answers your question.
Yeah, Arpit, your reflections?
Yeah, quite similar, but a little bit different. So what we realized is that building quality is very tricky. So, in metals, you would know there's a property called anisotropic. That is, it has properties same in all directions, right? If you were to cut it across any plane, the properties have to be similar. Now, this is very tricky to achieve in biomaterials because particularly for my side of biomaterials where we are growing mycelium, right? So it would have a favored growth in certain direction and not so favored growth in certain direction, no matter how optimized parameters have given them, right? So matching applications and matching properties is then sort of very tricky. by biomaterials themselves. What I've figured, what we are leveraging on is the science of composites. That you add paper in certain directions, and you add some other materials in certain directions. So whatever is lagging from biomaterial by itself is compensated by some other sustainable material, and together they can formulate what is required. Now this is something I learned primarily from this concrete itself, that concrete has very good compressive strength but very poor tensile strength. So we add steel in between. So that's how we developed our material as well, that we realized that it has very good compressive strength but it lacks tensile strength. So we add paper or we add fibers, or what can we add and what can we do. For materials, what my learning has been so far is that it requires a hell lot of research. One property is driven by 10 parameters, and optimizing those 10 parameters is an engineering nightmare. So optimizing those parameters and still delivering on quality. So just like Sowmya said that, she got some insights from the industry, that, the industry wants it to fit into the same process as well as have the same consistency. We also focused, let's just focus on what the industry is seeking. What we realized for our industry only seeks aesthetic properties. They don't want anisotropic properties. So let's not waste time in building anisotropic properties. Let's just give them the aesthetic best cushioning material that is required, and the packaging properties are solved. Similarly, we realized that our material has got very good thermal insulation properties. So next we are building ice boxes. Now ice boxes have been completely dominated by thermocol or styrofoam as we call it. There has been no alternative. The only alternative being polyurethane that comes in costlier ice boxes, but that can be replaced. So again, figuring out the right composites and building on the properties, identifying, go to the customer first, the typical MVP approach that we have in startups. Go to the customer with whatever you have, seek feedback, and be okay to to be bashed in the meeting, and then build up from there and keep iterating to rightness. Because if we go from the engineering mindset, then I would have started solving for anisotropic properties, which was not required.
Yeah.
And then I would have wasted, let's say, a couple of years in R&D. So the time is very limited. Dharaksha itself has spent almost 3.5 years in R&D. That's a very long gestation period already, right? So we have to minimize the gestation period. The only way is hear from the customers and just focus on the 1 or 2 properties that they are most concerned about, build it there, launch it, and keep iterating.
No, I think that's a very good point. I think to both of you, just a quick question before I move on is, like in case of concrete, there is ASTM standard, testing standards are very, very well known. In both of your field, I don't think they will be there, but if they are there, and would you see as an early leader in the space, it's also incumbent upon you to work and try to create those standards so that the whole ecosystem goes. So just a quick word, if Sowmya you can say, and then Arpit.
ASTM standards, I mean, see, those are very specific specifications for each material compositions. We don't have that. We're very far away from biomaterials on that. But what we do have is at least things like which prove that yours is a biomaterials, it's compostable, or it's those standards are pretty well established at least. You can't just take away a non-biological material and pass it off as a biological or recyclable material. I think today that's where the standards are. There are very early standards in Europe starting to look at biomaterials on a holistic basis, but still at an extremely early stage. There's nothing close to something which is published or widely accepted yet.
Got it. Similar at your end, Arpit, I would assume?
Yeah, very similar. Hardly any proper standards exist. But yes, what I personally feel is that we have to work a lot on building these standards. Reason being, so there are twofold reasons. First is obviously having the right confidence with the industry, right? So every industry we go to, they say that, give us a spec sheet. My spec sheet is just density, temperature, and a few parameters, 4 or 5 parameters. And all those things have no ASTM standard, in brackets. So that is not enough confidence, right? So my closure time increases. We have to educate a lot. We have to tell a lot, and we have to show all of these things happening. Second reason, what I feel why the standards, we have to work a lot on building standards, is to avoid cheap knockoffs in the industry. So what I mean by that is, for example, people get a lot motivated by seeing certain videos on YouTube, and they feel that they can do the same. And then what happens is that, if industry has evaluated some cheap knockoff in mycelium technology that has, let's say, not done enough research, and they realize that it fails, they should not write off the entire mycelium technology as a whole.
Yeah.
Right? So preventing cheap knockoffs from entering the market until they have done basic standardization, basic research is also very crucial for the industry to get the right gestation time till, you know, everything makes sense, till, you know, we reach the cost parity and everything. So these two reasons, I am personally of the opinion that together as a cohort, as an ecosystem, we have to work a lot on standardizing things and you know, help each other in introducing to the right stakeholders who could be important in getting these standards out.
Oh, great. I think Shashank, you have a perspective.
Yes, I mean, just adding to, I know I've taken a bit of time already, but just adding to the discussion that was happening there, I feel that there are two types of standards that are important. One is the testing standards and the other one is the product standards. At the start, the standards appear to be a little bit of a barrier to the introduction of new technologies, because it looks like the standards are not allowing you to introduce something that is not there in the standards already. But then once the standard is there for something, and once something meets a certain standard, for example, a product standard, the great thing is it gives the users the confidence of using that, because it is already certified by a certain standard. People feel more confident, and it may help in a faster introduction of the product in the market as well. I feel we have to have these standards, and we will always have a love-hate relationship with them. But what we probably need to do is to support a faster development and acceptance of standards. But they'll definitely be needed. Thanks.
I think in this thing, it's like it just shows the industry is still quite nascent, because, you know, the regulators start looking at it once there are enough people, they start worrying, okay, now is the time for me to bring in the regulations. So it's just that I think we're at a very early stage of this whole process. So, but yeah, I think bringing in regulations, policies to support it is going to be important in setting up a good industry.
And to that point, coming to Jagdeep sir, I think being a corporate, like, and both, I think corporate with India as a thing, but also a global large behemoth, right? So if you can give the perspective of what are Nestle's goals in the near term, how is R&D focused on this alternative material? Then again, linking to the discussion that we had, for you to accept any new technology from the outside, is it an iterative process, or do you say, look, this is the standard that I want to meet, and is your product meeting that or not?
No, thanks. Thanks, Mirik. So I think from our side, Mirik, I mean, I think as an organization globally, we have made our ambitions very clear. And whether it is about going net zero by 2050 or even short-term goals itself, that by 2025, 95% of our packaging would be either recyclable, if not, you know, I mean, into the kind of a sustainable sort of a direction around. So what it means for us is fundamentally, you know, three areas, if I were to put that in. Packaging is still, you know, I mean, one of our biggest areas, focus areas to try and build things around, to look at alternate materials, look at alternate technologies, to also drive some step changes. The second important part is obviously on the carbon footprint, where some of the key materials itself, like dairy, are, you know, been really high on the greenhouse gases. So how do we build that in? But more fundamentally, you know, I mean, we deal in food. Food is all about taste, and food is about nutrition. And you know, I mean, no one is going to accept a food which is sustainable but does not taste good. And I think, I mean, you know, recently, if you see the entire hoo-ha, what happened on plant-based. Right.
Yeah.
I mean, you know, again, it's a very fine line on where you work in and how do you define. And I think there was a point which Arpit made as well, that sometimes you can actually do a lot of disservice to the potential of that particular technology or that material by not having, you know, I mean, equally good products around, because the consumer who once picks up plant-based, which is not tasting good, would never come to that category, because I mean, it's a sort of a process of change that they will not really move in. The other part for us is to look at energy, look at you know, what alternate energy forms. So, for example, in India, we have now moved more or less to biomass-based boilers. and also with a backward transition to look at paddy straw, crop waste, to see that how can it fuel up. But one thing which I want to also make as an important bit is sometimes we get so fascinated with some of the other things, some of the new things which come in, we forget about the potential which the existing ones have as technologies around. And there are a few of them. For example, now we have got water positive factories. You are able to do that, and you can change technologies to almost double the extraction out of a coffee bean. So you can make huge step changes into this. And I think as a corporate, these are some of the areas that we are talking about. An important learning for us, as we work with the materials, has been to manage excitement. I think, I personally, I see, when you can, the most difficult job is to say no to good ideas so that you can work with a few great ideas. Because there is so much happening today. Every second day, there is something new which comes up. And what happens in an industry like us is you get excited and then you don't put the enough, the relevant energy around, and you move to the next one even before the first one has matured. So that's an important area for us. Are we open to the external technologies? Answer is yes. So for example, we launched the first ever launch in the country on biofolk or paper straws happened with us. And this was not Nestle technologies. These were external technologies which came in. They looked at what else can we do, and we partnered with a startup to launch edible forks, for example, in our kaba noodles. So we do work in. And here in the R&D center, we do incubate startups. And we had a startup which spent 6 months, with seaweed packaging around here as well, 3-4 years before. And it's important to understand that technology takes time. And I think, this is also, as I said, learnings. Once you look back, important to manage expectations, to say that this is the savior of the entire world and everything will happen from day one, is probably a part that we also try to look at. And you mentioned something earlier, which is about really making sure that we have got all the stakeholders together with a common goal, rather than individual planets which are working in isolation, and then the day the planet is opened up, you say, by the way, you were on a very different orbit than what we were talking about. So I think these are a few areas. It's definitely an exciting space. There is no dearth of good ideas, but I think we need to really pick up together which are those great ideas that we want to put concerted efforts, and normally it takes time to develop, evolve, and get into what Sowmya was mentioning in terms of standards and the part there. It takes a little bit of time to understand and build that into perspective.
Just a follow up, Harini also did touch upon the geographical nuances that need to be added to a product. And again, Nestle being a MNC, how do you see that aspect from a cultural perspective in India? And are you then working on products or working with the global R&D team in terms of fine-tuning some of the innovations that say come from a Western country, and how do you then get it to India or vice versa, right? So what's been your thought there? And
no, it's a very, very, very good question. And I think, just to put a perspective around, although it's a global organization, but we have got 25 R&D centers now, and we are one of them, which is a very regional center. The reason we are situated here is to really get the local intricacies in mind to see what works here. A packaging material which will work in an organized supply chain in Europe, from a barrier perspective, from functionality perspective, is not something which works in our country, where you have a product which is tossed around in the wholesale into a retail shop around. And you can end up with a much more serious issues around in terms of what do we bring in. The second part is also to understand the local part, whether it is regulatory, but also in terms of the ecosystem, the way it is developing. Example is on recyclable packaging, right? You can, we have a commitment. We have been changing at quite a significant cost, but how do we build the infrastructure locally to also recycle? And where do we go with that particular part? And it's very different than what it is in a European context, for example, I mean, where it's very clear people do sorting at the source. Here it was left somewhere else to build in. So those things, they become super important for us. And I mean, that is something that we try to also build in here with our R&D center around.
I think the point that you made around taste and is very, very crucial, because when I at least think about the transition, a lot of the transition is a B2B problem, like energy and cement, but something around food is such a sensitive challenge in terms of acceptance and cultural and those aspects. I think that adds a layer of complexity onto anyways a complex problem. So
the sacrosanct as well, right? I mean, the way we have grown up, we have grown up with certain things being told that these are good for you. To go back and tell people that, I mean, this is, by the way, something which is not there. Example is millets. Getting millets mainstream is not an easy part. And I mean, when we did our MVP and shop test, a lot of consumers came back and told us that for 20 years, we have been told oats is good. Why are you now saying millets is good? What is the part? Where is it coming in? I mean, for us, it is a poor man's food, which is not necessarily the tastiest option around. So you have to move through this journey around.
No, great. Thank you. I think coming to
Dr. If I can add one comment here, Mirik, because what was interesting, foods is a whole category, which is not just taste, the regulations are also very, very, very stringent. You can't just enter and put anything in foods. But at the same time, when you're, and this is like the interface of biomaterials and foods that we see, right? One is your requirement of, it has to perform as a product on ground, your consumers will like it. And then the second thing is the whole perception about the product. So for example, when we started looking at novel ingredients from seaweeds, in the Asian countries, the Southeast Asian countries, it's an absolute okay. I mean, you go to Japan, they'll give you anything you call seaweed and they'll eat it, right? On the other side, you go to the US or, a Latin American market and you say, hey, try this. They don't know, like, what is this smell? It's very, very perception oriented. So I think he's absolutely right. We're building consensus at a consumer level also. And this comes back to biomaterials, the topic we're discussing. Today we're saying recycling is very, very important. And it is important. There's a huge efforts going in. Europe has taken that stand as well. But the issue is with food contact materials, it's still not very clear how much of recycling you want to do. So what are the alternatives there? How do you address those solutions? So those become very important. This is not a discussion that's going to end today. I think this is just bringing in a lot of thoughts. Hopefully over the next few years, we'll have answers for this. But I think these are really relevant in making sure we're transitioning into a newer industry, which is all not just sustainable, but also good for the entire world and people in the long term. It's not a makeshift idea which you're saying that, I have to be by 2030, I have to do this, so I will just take whatever it is possible. So that way, I think bringing these pieces together with what will make this industry stand in the long term.
Professor Bishnoi, I'll want Dr. Saiyed and Uthara to join, and then we can take it further.
Okay. So, just wanted to add one word there. Water is something we're forgetting about when we're talking about food and recycling. So brings in another aspect.
Makes sense.
Absolutely.
Dr. Saiyed, I think you did mention at your introduction as well that you, or CCamp in a way, has worked on so many different technologies. I think just a insight in terms of the technologies around alternative materials, both from a big materials perspective in terms of packaging or plastics or those areas, but as well as on the life science sector in terms of these nanoparticles and things. If you just paint that picture, and again, some of the learning from some of the biotech side of things, can that be taken over into these areas where we are discussing, which is on even food as well as construction and things like that?
Yeah. No, thank you. I think it has been fantastic to learn so much about the material science, which I don't get to deal on every day basis. So thank you for that. In terms of the use of material science or new materials or the conventional materials, new applications, it has been actually greatly used over now decades at multiple places. You in your list that you had indicated, of course, the biological materials which get produced through the strain development and other things, which can be anything. And that's where the synbio or synthetic biology based applications will go, where you can eventually build chemical replacements, which actually will make a huge difference because they will have a less carbon footprint compared to the fossil fuel based chemicals that we have been using. And a lot of those will come. Right now, the challenge is that the reason it has not been cracked is because of green premium that it has. The cost is high, and hence that's the challenge. But everything was difficult and everything has become possible. So I think it's just the trajectory and the trend that one has to build in and look at the opportunity and go from there. So that is definitely, there are a lot of amazing things that are happening in there, right here on campus. In addition to the work that C6 Energy does, we have a lot of other people who are able to use different capabilities, including, replacing the chemicals in detergent industry, replacing the chemicals for textile industry, and do that. That's right from your campus. That is really amazing because initially the chemicals were we're using the chemical processes, then people tried plant-based, but the scale you can't have, hectares and hectares and hectares. But when you go microbial production of it, you can actually do a lot of it. So that's a good opportunity that's one. You also talked about lipid nanoparticles and many other things. Lipid nanoparticles are right now phenomenally hot in terms of its applications, right? In terms of delivery. A lot of things you mentioned about the COVID vaccine component, but in general, right now, the delivery of molecules inside the body, be it a protein, be it in DNA, be it RNA, is so hot because then you will have a very precise targeted aspects you can do. If you can look at work from Bob Langer's lab at MIT, you realize that only based on that chemistry, they have tens and tens of spin-offs or much more than that from one lab, just based on one basic technology. And that is really amazing work that they have done. So but a lot of other materials like graphene has been used significantly over years in applications which are in bio, right? But graphene has also very good antimicrobial properties. It has been used by some of the people in urinary catheters to prevent the biofilms. So there is a lot of new components of the material sciences which has been done at JNCSR across the road for us. People are using them for many other applications, using new materials for, again, infectious biology. There are materials being used for, optics, imaging, which has specific properties to fluoresce under specific circumstances at a very low cost. So there is a lot of excitement in terms of materials out there. And I think what we touch base is a very good spectrum from, in terms of the bio-based production to the other traditional materials used in bio. And I think that's, I would say that this space is going to grow further and further. I think most of the applications are going to be interdisciplinary. I have no doubt in my mind. And I think if somebody looks at any field very, with a single view, it's going to be very difficult. So I think that's the excitement about this space right now. And that's the excitement about the discussion that we are having.
I think a couple of questions and follow-ups. And I think people did mention that ease of entry. And when you talk about ease of entry in a life science space, I think the barrier is even higher. Like when you are saying that let's introduce a graphene or LNPs and things like that. So do you think there's an opportunity in the interdisciplinary nature where, say, if there's a technology which is suited for life sciences, but if they can be applied into a lower barrier to entry industry first, so that the testing results can be faster? And again, I don't know whether this kind of thing happens, but if you can just highlight your thoughts or in that perspective.
Yeah, no, people do that. People sometimes take something that is so risky, and hence, if they had to do something and they don't have the breadth to go all the way, they go to areas like veterinary or others or topical in nature, where you actually are not actually doing the invasive. You're doing topical, or you're going veterinary, or you're going plant-based, where one could do that. So at least you are getting the things ready by the time possibly you will be able to validate it further. However, the most exciting innovation space is they do take risk, and that's good, because every time we actually kind of try to, settle for a lower bar, it will not allow us to succeed. So I think many of them actually are going all the way. So right now, people are actually going to working on ways like, if I may say so, LNP, which will go and change, eventually be able to help with, inside the, as I say, in vivo gene editing, or so that is really top notch. You will go inside, change within the cell, not only you'll deliver, you'll do the gene editing there and go from there. And that is something, those are the new era where we'll have to, because one had to thought that if you had to gene therapy, you have to take out things, you have to change it, and then you replenish it, right? Not anymore. You actually can deliver something, it will do its work, and then come out or get used up in a manner. So those are the there are both approaches, but the ones which are eyeing high are the bigger hopes for us to actually solve societal problems.
Thank you. And I'll come to some of the points later, but I'll just to get Uthara in. Hopefully, I pronounced that right. Apologies if I didn't. So, for a question for you would be like, you are focusing on plastics and textiles. I think we did a talk a lot about the plastic side in a ways, whether biomaterials. So, if you can just tell about the textile space and textile, what are the alternatives that are being looked at, and both from a perspective of pure material alternative, and also I know in textile there is a lot of process innovation that takes place, whether you can, the dyeing process itself, you can add supercritical CO2 then instead of water and things like that. So how have you scanned the landscape from a textile perspective? And obviously you can touch upon plastics as well, as Social Alpha, which is one of the pioneers in early stage deep tech investments.
Yeah, I will touch upon both of them a little bit, because both are big problems. So plastics, for example, when Dr. Shashank was talking about global emissions, plastics produces anywhere between 3 to 5% of global emissions, and textiles even more, like 5 to 8% of global emissions. So when we look at plastics, it's imperative to look at new materials, but of course, all these solutions will run in parallel. We can't get rid of current plastics. So that definitely will continue to happen while we look at new material innovations. Now, when we look at new materials, it has to be new materials that fulfill functional properties, performance parameters of conventional plastics for various applications. So here, largely, you have solutions for which are bioplastic as solutions. But the problem with a lot of bioplastics today is that they are only industrially compostable. So for example, if you look at polylactic acid, which is one of the most common bioplastics that is available in the market today, it's only industrially compostable, and in India, you don't have such kind of facilities. So, to address this gap, you also need solutions that are biodegradable in ambient environment. So, PHAs, which are polyhydroxyalkanoates, they are a potential solution, but today they are very expensive. So, so PHAs are essentially bioplastics that are produced by microorganisms. It's gaining popularity due to the ease of compostability, but it's expensive. So can we look at innovations that can increase the yield and possibly bring down the price for something like this? Of course, there's seaweed, algae-based materials. There's also mycelium-based materials. We have startups here that are working on these. So these kind of solutions are also needed in parallel. And lastly, I think we need to also look at recycled plastics. This becomes very important. And by recycled plastics, I mean not just plastics that are made through mechanical recycling, because what mechanical recycling does is it brings down the quality of plastics. So we also need to look at advanced recycling methods, where you have depolymerization that can happen either through chemical or enzymatic recycling. What this can do is it can create monomers, which can then be repolymerized to create high quality recycled material. And this can also become important to address solutions which, problems which, Nestle and Saint Gobain spoke about a little bit, right? You want high quality recycled material. So how do you get that? So that sort of advanced recycling solutions which produce new materials, you can call them new materials, would also become very important when we're looking at plastics. So mainly, I think in plastics, these are the kind of solutions we are looking at. Advanced recycling solutions which can do depolymerization coupled with these new materials, that I spoke about. Coming to textiles, again, here we're looking at new and alternative fibers. The main problem with textile is, of course, the high amounts of chemical and water that is used. And the materials that are problematic are cotton and polyester largely. Right, so people are looking at sustainable alternatives for these and processes, in the manufacturing of these. So here, examples could include fibers made from other materials. Hemp is one example. We have a startup in our portfolio that does hemp-based fibers. We also recently saw Dr. Taslimarif, Saiyed, he touched upon dye innovation. So we've also recently invested in a startup that's doing microbial dyes. So this would be a replacement for synthetic or even plant-based dyes. Plant-based dyes are a stopgap solution, but like we discussed earlier, you need a long-term solution. So that would be, another example. Then leather is another thing that a lot of companies are looking at. So bio-based leather is also a solution that has a lot of potential. And it also has a, ease of entry into the market because it's not commoditized. You can price leather at a higher price. So one of our portfolio companies, Fool, they are also looking at making a bio leather from flower waste right now. So yeah, I think these are some of the solutions. And at a very early stage, a lot of these solutions require a lot of funding and support. And I think that should also be, the kind of conversation we should all be having as ecosystem stakeholders. And even in textiles, recycled material again becomes important. Today, some polyester is made using recycled PET bottles, but can we look at polyester to polyester recycling using advanced methods? That's another solution. Somewhat futuristic, but holds a lot of promise.
No, makes sense. And you touched upon a very important point, which is funding, and I'll get Swapna onto the spotlight in a way. Like Swapna, paint a picture, two pictures. One is obviously your reflection on the panel and the materials, but when we discuss about the long gestation period, there are going to be so many valleys of death. And what I feel like even Spectrum or Social Alpha and others, we are still in the early stage of funding. And you would be also sort of at the next stage. But I think we still require 2-3 level more of funding and in materials cases. So how do you think the Indian financing industry, and I'll use the financing more broadly than only VCs, looking at the material space and what needs to not change, I would say augmented in that philosophy. So, and happy to hear your thoughts on that.
No, absolutely, Mirik. I think I actually am very optimistic that ecosystem is coming together to fund some of these breakthrough technologies coming from India. And I think this is a function of how we have observed the last 10 years of really India coming of age, right? If I think about my last 10 years, it was absolutely about investing in deep tech coming out of India, right? Be it computer vision, be it AI, be it space tech, be it drones. But as I think about next 10, 20 years, and that's how Avaana Climate and Sustainability Fund came into being, Anjali has also been a stalwart in the ecosystem. And what we said is, look, someone needs, if India has 20% of the world's most vulnerable population, climate change is real. At least there is nobody saying that is not true anymore. And the current way of doing things is non-sustainable, which means technologies have to change. And technologies have to change in the way of our being across sectors. So very sector agnostic lens, but earlier someone mentioned water. We've been talking about how technology is changing. We're not thinking maybe what material we are replacing, but what properties we need to change wherever, be it built environment, be it packaging, be it agriculture, across the board, how do we need to change? Which means a lot of this will actually come out of labs. This will be product innovation. A lot of this will actually start from scratch up and will need different capital stack. I think fortunately in India with say CCAM, BIRAC, we have the early incubator acceleration ecosystem. Then we have likes of Social Alpha who are doing the good work. But as you think about coming to a pre-series A, series A, I think that's where we found the gap, that there were a lot of generalist VCs in India who would always come in and out as flavor of the season, right? Abhi AI acha hai, chalo karte hain, abhi B2C acha hai, karte hain. But climate actually needs a very focused effort because again, to your earlier point, right? You need to bring the entire ecosystem together, policy, corporate, technology, financing stack. even if one of those pieces is missing, I don't think we can move the climate ecosystem forward. If I say, look, I have 100 billion, 10 million, whatever capital, and I will fund Indian startups in climate technologies, I don't think I will move the needle. Unless say Jagdeep says that Nestle, I'm going to adopt it, right? Or Harini says, I'm going to adopt it. Or we need an accelerator or incubator like CCAM says, I will give that initial reactor for them to work, right? So I think the whole ecosystem sort of really needs to come together was the thought, but we also understood that capital was an important, crucial step in that 1 to 10 journey. So we came with capital plus all these relationships saying we will build the ecosystem together alongside everyone else. And I think that is our sort of thought that capital is needed, different stacks of capital will be needed, equity, debt, working capital, grant. We need to work with all stakeholders. Also, we can't sit in silo and build a company. We will need the corporates, the regulatory, the academia, everyone involved. So, which is, I think, the fact we were discussing, right? Why are we doing Avaana India Climate Week? It's not our day job. Our day job is to invest in companies, make money, return capital to the investor. But unless we do this, the ecosystem really won't be built the way we are thinking that it needs to build over the next 10, 15 years. So I would say that we are a small sort of effort in getting the capital stack to move. But again, once we invest, for every dollar we invest, we put $2 aside because we know there is a value of death. We know there will be, if the company promises us 12 months, probably 24 months, tak to product aayega hi nahi. So how do we go through that value of death? So I think those were the conscious choices and decisions along the journey. And the third thing which we are doing is we are actually thinking about what is the next pool of climate capital, where will it come from, right? So a lot of late stage capital conversations, we have to not only do India, but globally. For example, after this, Anjali and I are both headed to New York. The reason we are there is we'll probably find some GTM opportunities for our portfolio, but also a lot of capital pool providers who need to come to India and start allocating capital. Again,
I can touch on that point because that's a very important point, that getting capital, global capital, and when you see at global capital, and my scene also has been that they are so much focused on solving for the West in a way, right? They want to solve climate change for the West. Doesn't make sense, right? You need to solve it for the global South. So if you can just highlight a bit on that, like how do you see that progressing? And also, again, I'll touch upon this because this is important. From a regulatory perspective, it becomes a challenge for a lot of these funds when we talk to them to set up offices in India, to get the capital in, out, and flowing. They require a certain minimum threshold. So if you can just touch upon that and how that can lead to more capital in the system.
Yeah, I think there is always that hesitance, like you said, Mirik, right? It's easier to invest in my backyard. So I will go invest in North America, Europe, easier understood. Also, most of the developed market, to your point, is focused on mitigation. So they have done whatever they had to do. Now they're focusing on how to mitigate whatever is out there. While we are thinking about adaptation, right? How do we continue to build as we are growing? So it's a different narrative that needs to be shared. But I think a lot of people now also understand, and I think it's a good thing about India with the public markets, with the kind of startup, the technology ecosystem that India has built. Folks also understand that I think Europe is sort of getting saturated. US is also sort of coming down in terms of growth. China has become very closed. Brazil has its currency and corruption fluctuations. So maybe India is the next growth frontier. So at least I think that tailwind is helping us. But I think we often struggle with the same question, right? It is hard to get money in and out of India. Then we have to explain, look, Walmart invested and Flipkart happened. SoftBank has invested, other funds have invested. India really is a growth frontier. So you're right. A lot of this is actually narrative building and take away that sort of thought process that India is hard to invest in.
Okay. So I think been a pretty good panel. So I think the key aspects that we would want to take, and I'll get to every one of you once, is two questions for everyone. Similar one obviously is from a policy perspective in the field that you are doing, what is like the one or two ideas or thoughts that you would want to see? And obviously we will take a note of that. And secondly, I think a lot of us discussed about not working in silos. So from this particular panel, is there an area within the panel, that's fine, but overall that you feel that more interdisciplinary collaboration should happen? And if so, if you could specify an idea that is emerging on that front. So I'll start with Professor Bishnoi.
Thanks. So I feel that apart from financing, we've been discussing financing, something that we also need are kind of like accelerators. In a way, setup that can help in moving the technology quickly from the concept to the field and bringing together like-minded people from different aspects of the industry. For example, I can take an example of cement, bringing together like-minded people from researchers to producers of cement to people who will be using the cement to very quickly demonstrate that a new technology can be used and to figure out the advantages, disadvantages, and so on. That is something that would be needed. And these kind of accelerators would have to have people from different fields. One of my favorite areas right now where...
Sorry, one sec. I think Dr. Saiyed, you need to leave. Can you just give your final comments? I just got your message. Then we can take it. Or have you left? I don't know. I think he has left.
You're on mute.
You're on mute.
Sorry, one is a human at the end of the day. That's good. So I think I would echo what I think Professor Bishnoi is saying. Very importantly, I think to be able to further go into this, I think we may have to take there has to be a little bit more risk support at the development level, which happens in collaboration with academia, which comes from academia, and also possibly a little bit of risk that could come for startups from the government funding, as well as the late stage. I think what we have seen is that wherever we have done well in terms of innovations, little, not yet, I think it has been our ability to take risk and support risk and take the risk away from the innovators. And if we can build scheme and we can instill freedom from fear of failure from them, if we can take away that thing from them by having a 3 to 5 years of continuous support, I think it would allow people to unleash their ideas. Some ideas will stay, some ideas will drop, as we know. That'll be fantastic. And I think using the national labs, which are like ours and others, is the right way to go to ensure that it's not done in silos. I'll just possibly stop here. Thank you.
Thank you so much, Dr. Sayyid. No, I'll definitely reach out to you separately for some other ideas.
Thank you. Sorry that I have to leave. Thank you so much. Bye-bye.
Professor Bishnoi, sorry to cut you off, but if you can...
No, thank you. So one of the aspects that we usually miss in these accelerators is the policy part. So maybe get the right people from the government, the administration to help us push the policies through as well. Things like green public procurement and things like that will probably help in getting a lot of developing markets for these kind of technologies. An example that is these days my favorite example for a technology that would be cross-cutting and that will help in which is related to construction, of course, but in the end, it's related to the steel industry, the chemical industry, and to the cement industry in the same time is non-steel reinforcement. You mentioned in the beginning that steel and concrete got together and gave us the skyscrapers that we have today. But one of the major limitations of being able to go down to lower emission cements is the steel. Protecting the steel makes it difficult for us to go down to lower clinker factors. If we can develop other non-steel reinforcement, which is there, but then probably it's the scale, the economy of scale, which is not working out right now, trying to figure out which are the best options. There are so many options, carbon, glass, basalt, many of them are being converted into reinforcement, and taking the help of chemicals to convert them into products that can be used today in place of steel will help us bring down the clinker contents in cements even further. Something that has been a limiting factor in our research. So that's where people from different areas will have to get together to be able to solve those problems.
Perfect. Harini, from your perspective, thought on the policy at the corporate side, how do you see that working, and any interdisciplinary ideas that you feel that we can take up as a group?
Yeah, so as I was mentioning, we at Gobain are also moving towards alternate fuels and renewable energy and secondary sources of raw material. Across our many businesses, glass, motors, gypsum, and so on and so forth. And very recently, Gobain Gyprock India has unveiled the production of low carbon plasters near Chennai. It's the first company in India to manufacture low carbon plasters. right? And we are trying to reduce the global warming potential by over 40% during its life cycle by using these kind of plasters. How we achieve this is obviously through, converting to alternate fuels and so on. But what we also notice is there is a huge demand supply effect. Many of these companies are going towards alternate fuels, say rice husk, sugarcane bagasse, and so on. Since there is a supply demand effect, there are at times where these alternate fuel becomes expensive than the normal fuel. If government policies can be directed towards that, it will help companies like this where the focus is on bio-based materials, and that will be really, really very helpful. That is one thing that came to my mind. And the second thing is, of course, I will connect with Professor Bishnoi separately on the alternate LC3 cements, because we are into motors for tile adhesives and so on. So maybe we could do some collaboration there. We are always in lookout for startups working towards our vision on lightweight and sustainable construction. So if anybody, it need not be just on the lightweight and sustainable construction, it could be also in the packaging areas, since our products also need packaging. So we are open for any kind of co-creation.
Can I just say I'm very happy to hear this, Harini. That was a purpose where you and Bishnoi sir have connected and will work together.
Sure.
Yeah, Arpit, I think from your perspective, I know you're an early stage startup, and what sort of thought process, both in the near term, is there any policy benefits that you think are important, but also in the mid to long term, as this whole sector grows, right? It's a nation sector at the end.
So, Mirik, for me, it's very clear that access to standardization agencies and having a more proactive standardization as a policy intervention, that is something that I believe that for new materials particularly is going to be the pivotal. And I've already highlighted the two reasons. One is to give confidence to the industry, and second is to avoid cheap knockoffs, because that hurts the entire research ecosystem. One technology that I'm particularly very excited about in collaboration, that I'm surprised that nobody talked about, is use of AI, particularly in biotechnology and material space. So I have had a taste of use of AI very recently. So there were a few chemical processes that we were trying in order to bring down our energy requirement for sterilization process, and we required certain reagents, etc. So we were able to get the right amount, right concentration, right quantities of reagents in seconds, whereas this approximation would have costed us getting expert in chemistry onboarded as consultant, and let's say a month of entire arrangement to be figured out. And then the experiments we conducted in the next month, I was able to get those answers within a couple of minutes, and we were able to conduct those experiments on the same day. So this speed of execution of ideas is something that I have not experienced before in my career of last 10 years of doing innovations. Whenever, as soon as you have an idea, all the data points, all the balancing, all the reagents, everything can be gathered within minutes, and you don't need like the experts sort of opinion. So this empowers generalists like us into faster execution mode. This faster execution mode is let's say the basis of the entire industry and the startup ethos. So I'm very excited to see what AI tools as they are coming, not just for making videos and social media, but what really concrete can it contribute to research and development, particularly in materials and biotechnology, and primarily for me the biomaterials, because that's the intersection we are working on.
I think, Arpit, you made a very, very valid point, and it's interesting to go 1.5 hours without mention of AI in these days. But I think what you made, I completely agree with you. Where I see the AI's biggest potential is in the material discovery and material optimization space by far. Because what happens is the solution scape is so vast at the end of the day. Like you can tinker 0.1% and then you have 20 parameters going into it, and then you can. And that's the example of Google DeepMind, right? When they did the protein discovery and how they were able to accelerate that whole thing. So that's a very valid
exactly.
First thing that you mentioned, I think we can just use the reference in the bioenergy space, where the government is now trying to standardize the biomasses in terms of grades. So instead of looking at this is a cotton stock versus a mustard stock and everything, you can only get 3 types of biomasses based on the calorific value. That's an initiative that I am aware with the MNRE is doing, but maybe something on those lines and taking that as a reference can be a touch point into the broader biomaterials. Sowmya, similar question again from a policy perspective, and again you are sort of much ahead in the journey. How have you navigated it, and how are you looking to for some interesting interventions from that perspective?
See, I think policies are still evolving. I think everyone's spent a lot of time talking on how much more evolved policies that we need to do this. Sorry, 1 second.
Maybe if you Sowmya requires time, we'll go. You're fine?
Yeah. So I think policies is something that we'll have to continue to develop in this space, Mirik. All of us are watching out and seeing how that whole thing pans out. But I think the other important intervention in this space which is required is questioning how you can modify the existing norms of packaging or use of plastics, because that doesn't get done very often. For example, today we say that I use PET for everything from packing a biscuit packet to, a water bottle. You don't need those properties across the line. Certain specific properties might be required for it, but since we're all so used to doing it and it's so easily available, it's cheaply, affordably available, it just gets used. And then every time you want to bring in a new material, you want to talk to people, then convincing them and showing that I don't need a spec sheet exactly to match what is existing plastic. I think breaking those kind of paradigms, and more corporates are starting to realize it. They're willing to question it and look at these answers. But I think those need a big change to start looking at real impacts, because let's say companies like us, we come up with technologies, but the people who take it to the end consumers are still the large consumer companies, right? So having these discussions with them and bringing a change in the thought process on why do you need this material here and why not? I think that thought process is something which we are seeing is more and more required. Apart from, the other points that we just discussed a while ago. So in general, I think there's a lot of key things which need to be broken to really, kind of move over and say, okay, we started building this industry. But I think all of these points are in the pipeline. I think that was one additional point I wanted to add, before we kind of close for today.
No, I think what you said is, and I know in the concrete space where going from specifications of input to performance-based specifications, and I think that Dr. Karen from EPFL with Professor Bishnoi and trying to change that landscape is there, because otherwise you only say that I need this much mixture of input X, Y, Z, and that's my answer. And rather than going to strength all the property based thing, like if you require these properties, then when you find out you don't require those properties, then you can use a material suited for that. So that's a very valid point. I think obviously how do you structure it from awareness to the policymakers is another question, but it's a good thing for, I think, us to take out of this. Jagdeep, I think from your perspective, again, how do you look at the policy space, and any thoughts at a corporate level that you would want to think about?
No, I think a couple of areas which I would want to cover, and I'll just build on what Sowmya mentioned. I think in some cases, tackling larger cross-industry problems, right? I mean, whether it is plastics, energy, we really need clarity on what the policy is trying to achieve. The problem today is if it is piecemeal, looking at only a short-term, immediate-term kind of a solution, you will end up doing things which in the long term can create more harm. So if we look back 10 years, 10 years back, biodegradable plastics was one of the big areas to be working on, and a lot of people were doing that. No one was aware what will take to get into microplastics as as a contamination all the way across into our water systems, into the part there. So I think this is important that from a policy point of view, we at least pick up what are the core focus areas. What is it we are trying to resolve? Whether it is plastics or it is nutrition in this particular country from a food point of view, I think from our side, it's important that we build this in. Unfortunately, from a policy perspective, we have got two extremes. Area A is where there is nothing which is clear in terms of a part and there is a piecemeal solution. On the other side, in certain categories like us for food, we also have a very, limited kind of a scope to try new materials. For example, a regulation to make a biscuit or to make a noodle, for just as a casing point, goes with only a few positive list of ingredients that you can add in.
Yep.
And anything new that you were to put up. For example, if I were to use a side stream for proteins, right? Which is today it is wasted. But from an oil mill, if I were to pick up a side stream and use it for protein fiber, which is one of the key issues in the nutrition of this country, I cannot add this in. And then it is a long drawn process, right? And it is important that from a policy point of view, we see these opportunities which are a little bit ahead of its time, so that industries, startups, other partners can start to build onto these. So some of these themes are needed, around in a few areas. And I know what I'm saying is very specific. It may not directly apply to, to certain other segments like cements or whatever, because the standards are a bit different, in terms of the way they approach. But in some of the areas like food, we have not evolved from the old prevention of food adulteration mindset to a forward-looking, kind of a part which says, as long as it is safe, these are the norms that you need to follow, but you can move, and therefore it opens up the space a little bit beyond what it is. I think the second point, which is probably the beauty of us getting together here, is also something that we started to interact, with Swapna, and team also reached out from Avaana quite a few times when they're evaluating certain new ideas or technologies or even startups. I think the understanding in forums like this, how can we at early stage really pick up something that we do not end up, just being excited in a small part, but we see an end-to-end part of where we see opportunities, but also what are the derailers that we also see in terms of applying those technologies. It could be about, the setups that larger players have. It could be about how do we use, what are the points there. And I think an output of these has to, in my view, come out and say, what is a logical step in terms of scaling up something which is novel? How do we start? For example, food contact in a bioplastic is very difficult to achieve because of migration, because of other issues. But can it be, part of either composites, that was mentioned a little bit before, or can it be secondary packaging to start with? Does it really need to get into this space, and then it evolves and it can come to a category like food, right? So not everything will go from 0 to 100 on day one, and that is when we either keep on writing off things and moving around onto this. The last point from my side is a level playing field. We unfortunately as a country have got this whole dichotomy where there are two extremes. You have got certain corporates which will live on sustainability. They will invest even if it is more cost and more effort that is being put in. But on the other side, you have got the complete other extreme where people don't even take care about the basics on food safety on certain parts around. So I think very, very divergent in terms of a view. So I think from a policy point of view, how do we at least allow these things to be spoken about? How do we allow consumer to have some sort of a pull and desirability for this? Because unless there is a pull from a consumer for fast moving consumer goods kind of a perspective, consumer facing products, you can push as much as you want. It will not turn the tide in a kind of a major way.
Thank you. That perspective is quite important. And I think, so again, policy, one is more direct intervention for materials and one is a more holistic industry-wide thing where if you're having a level playing field, then obviously you can effectively experiment more with materials to begin with, right? So That's fair. Uthara, I think from your perspective as an early stage incubator working on deep tech, do you see that this collaboration with government in terms of, and I know we had CCAM, so that's from a government perspective, but how do you see that can be even better? I know there are early offshoots, BIREC is doing some good work and things like that, but what are the other areas that we can take it to the next level?
So I think I can, people have covered everything, but I'll break it up into 3 points, right? First is at the R&D stage, what the startup would need. One is especially new material startups, they require a lot more funding than what is currently available, whether it is in terms of grants or any other kind of non-dilutive capital, right? Maybe the government is doing something today and startups are maybe able to access 1 or 2 crores, but not more than that, but a lot more is needed. So I think that's the first area where there could be some government intervention combined with also access to R&D infrastructure. So for example, to take fermentation technologies today, there is some that is available at certain government institutions, could be CCAMP, could be in Bangalore, the Bangalore Bio Innovation Center. But there is a stage, for example, we've understood that there is a problem where startups reach a 50 to 100 liter scale of fermentation where it's very hard to find infrastructure. So working on that infrastructure along with higher amounts of funding, this would be very important at an R&D stage. And I think the government can play a huge role here. We've also, had some of these conversations with government. So I think then coming to the second point, policies and, all the points that everybody mentioned, I think we can take a consortium-based approach to talk to the government. And ideally, this should be something that the industry leads because they also understand the requirements the best, right? What is needed by the industry. So the industry should lead this sort of consortium-based activities, and other stakeholders could be startups, investors, R&D institutions, corporates, etc. But to talk about, one is the incentives that a lot of people spoke about for sustainability and cleaner technologies. 2 is also clarity on standards. So for example, in the extended producer responsibility, there is a mention of bio-based material. But what exactly is this material if it has to be exempted from EPR? That is not defined. And if people are using PLA, where is it going to get composted? That is, so this sort of clarity will only come in when you take this sort of consortium-based approach. So that's the second thing. And the third thing, these first 2 points can lead to the third thing, which is market access, working with the likes of Nestle or Saint Gobain, where pilots can be initiated to at least see whether, this product is meeting the standards. And if not, what else needs to be done? We did something like this with Unilever, where we ran a challenge where we selected 5 startups and we tried to see if they could fit into Unilever's supply chain. I think, Mirik, you're aware of Ashaya. They've been trying to work with Unilever to see if their recycled plastic can be used in Unilever's packaging, their toothpaste cartons and things like that. So I think these 3 points. One is infrastructure and funding at an early stage. 2 is consortium-based activities for these policy interventions and standards. And 3 is market access, in collaboration with industry. Yeah.
So I think, first, thank you, Aaron. I think it's been a pretty enriching panel, and the diversity in terms of the stages, types of corporates or organizations is quite vast. So thank you everyone for that. I think the perspective, I'll take Uthara's point on that, is the translational research as a concept where piloting is required. That is becomes very, very crucial in materials, even more so than others. So actually, I'll just give an example what we recently did with the IIT Bombay when we found out these membranes had a pretty similar problem. Everything is done at the tabletop, but then how do you take it to the next level? And the industry, to Jagdeep sir's point, they also require solutions which are at a certain level, right? You cannot give a very lab scale solution and say, look, like now industry should adopt it. So what our thesis, how it has been evolving with this establishment of this membrane center, hopefully early next year, we want to take it to the next level and work almost like on a translational research initiative across the country. And we actually have identified 32 such centers, and interestingly, a lot of them are around materials. And a lot of the things like you mentioned on capacity of fermenters. So there has to be publicly available capacity. And when I mean publicly available, I mean not at a private company like an Aarti Industries or a Nestle. It has to be at some government institute where it is accessible to people to try out things. And I think that's also a key takeaway for all of us, that how can we ensure that, and in those centers, that is where the ecosystem collaboration has to take place in terms of advanced market commitments, whether it's, if like you hit certain thresholds, then there is a procurement order at the end of it or things like that. So we would require nodal points specific to the materials and application lens. And I think we anyways are working on something, but this taking a lot of these inputs from this panel, using Avaana's help as well, we will try to create a structure in which this can be more put to the ground. So I think, no, good. We are on time, early on time. Thank you everyone for the whole insightful discussion. Thank you, Swapna, Anjali, and the Avaana team for the opportunity for Spectrum to host the panel and try to moderate it in whatever way and form we can. And yeah, any last comments, Swapna, or we can close?
No, it was very insightful. I was taking a lot of notes and sending live messages to my team. Have we thought about this? Have we done this? I learned what Arpit was using. He's using Llama for everyone else. So I think lots of notes to take and learn from each other. But I think, Mirik, you're right that I think we need to put something on the ground so that this whole collaboration comes to life, because I guess across forums, this is one point that we've been discussing, right? How do we get more scale out of the startups?
Makes sense. No, great. So thank you everyone, and wish Avaana's Climate Week is, I think, on the road and doing well, and hopefully it will do pretty good things in the next few days, and looking forward to participating in the future as well. Thank you.
Thank you everyone for your
Thank
time.
you.
Everyone.
Thank you.
Thank you.
Bye.